The topic of today's discussion is how are we going to interface infrared sensor, or in short IR sensor, with Arduino, and where these IR sensors are primarily used, and how to take advantage of IR sensors in practical applications. So that is the topic of today's discussion. When it comes to IR sensors, there are two types. One is an active IR sensor. So the one that is represented here is an active IR sensor. The one that is shown on the right is passive IR sensor, in short PIR. PIR stands for passive infrared sensor. So let us see what is the difference between the two and where exactly we use them in practical applications. When we say infrared, we know that the wavelength of the light, you have the gamma ray, we have the X-ray, we have the ultraviolet ray, then we have the visible spectrum here in the middle. So this is my visible spectrum or visible light. This visible spectrum is where you can actually visually see your light, starting from violet, indigo, blue, green, orange, and red. It ends at red. This is your visible spectrum. After this visible spectrum comes your infrared. Wavelength of this, the visible spectrum somewhere starts at 380 nanometers, and the wavelength of red ends somewhere at 750 nanometer. So this entire wavelength starting from 380 nanometers to 750 nanometers is what we call it as visible spectrum, or anything or any light between these two wavelength range we can visually see. Any wavelength beyond this is not visible for human eyes. You cannot visually see that light. Such a light we call it as infrared light or IR light. Sensors that work around this infrared light, we call them as infrared sensors. If you see the wavelength of the visual spectrum, it starts at 380 nanometers for your violet, and it ends at 750 nanometer for red. So all the other colors will fall in between these two. So if you are using a light emitting diodes like blue LED, red LED, green LED, yellow LED, etc., these light emitting diodes emit light which fall under this visual spectrum. Okay, so a light emitting diode is essentially an electronic device. When you apply some current flowing through this device would emit light. This light will fall under any of this visual spectrum, somewhere between 380 nanometers to 750 nanometers. If the light goes beyond 750 nanometers, if the wavelength is beyond 750 nanometers, then it comes under infrared range. Okay. If an LED emits infrared light, if I pass some current, if this LED emits infrared light or invisible light, which cannot be visually seen by human eyes, then this LED is called IR LED. Okay. So we find unique applications for this IR LEDs. Of these two, one becomes my IR LED, the other one becomes an IR receiver, which receives this IR light. Now, if you see this, where do we use this invisible light or IR light? The most predominant application is our remote control. The other most widely used application of this IR LED is security application. As I told you in the beginning of this lecture, there are two types of infrared sensors. One is an active infrared sensor, and the other one is passive infrared sensor. This passive infrared sensor, in short, it is called as PIR, passive infrared. So what is the difference between active IR sensor and passive IR sensor? The active IR sensor normally has two parts. One component is called a transmitter, the other one is called a receiver. The transmitter is the one which emits the IR LED, IR light. The receiver is the one which detects the IR light. So if your IR sensor consists of two components, one transmitter and one receiver, transmitter is normally a light emitting diode, LED, which emits this IR light. Receiver is normally a photodetector which detects this IR light. If you are going to use a transmitter receiver pair for detecting IR sensor, then we call that as active IR sensor. This active IR sensor is what we use in all our remotes. In remote, if you see the tip of the remote, the tip of the remote is normally associated with the IR LED, and in the television screen, somewhere in the corner of the television screen, you will have the IR receiver. So when I pass this remote, this IR receiver is receiving the commands coming from the remote, and it changes the channel or increases the volume or whatever it is. So the television remote control system comes under active IR LED or active IR sensor. Passive IR sensor, on the other hand, will only detect the IR radiations, which means it has only receiver, which means it only detects, it doesn't have transmitter. So that is the major difference between passive infrared and active infrared. We will start our discussion with passive infrared sensors or PIR sensors. The one that is shown on the right is your PIR sensor. Normally, it is normally available in the form of a dome-like structure, like our Auroville dome. You have a dome-like structure. Within this dome-like structure, you have your sensor position. This dome-like structure is essentially a lens which will collect all the infrared sensor and focus that on the sensor that is present inside. So if you see the anatomy or the structure of this PIR sensor, this PIR sensor is at the outside is having a Fresnel lens. Okay, so the dome-like structure, whatever you are seeing, the dome-like structure is the Fresnel lens. Okay, the job of this lens is to collect the IR radiations which is falling on the sensor and then focus that towards the sensor. This dome-like structure I am talking about. Okay? This is the lens. Followed by the lens, you have the IR filter. The job of the IR filter is to allow only the IR radiations to pass through. It will only allow IR radiations to pass through. What is a filter? A filter essentially filters certain thing. Infrared filter will allow the infrared waves to get through, and the other visible components are filtered here. Okay. And finally, you have the pyroelectric sensor. This pyroelectric sensor is what is the detector, which detects the IR light. So there are three components. First one is the lens, the dome-like structure. The job of the dome-like structure is to collect the IR radiations and then focus them to the actual pyroelectric sensor, which detects the IR. And in between the Fresnel lens and the pyroelectric sensor, you have the filter, IR filter. The job of this IR filter is to filter out the visible radiations and allow the IR components to get through. So that is the principle of operation of this PIR sensor. This PIR sensor is widely used in security applications. Say, for example, I have a room. This is a locker room, let us say. This is the door. So this is the safety locker. So I want to secure this locker and I want to detect whether somebody is entering this secure place or not. So what I would do, I would take our PIR sensor and position this PIR sensor like this and another sensor like this, so that it covers the entire room. We can use two or more sensors, not necessary that you have to use only one sensor. So the moment somebody is crossing the field of view of this particular PIR sensor, this PIR sensor would detect that and then intimate it. So we have to capture that signal coming out of this PIR sensor by using our Arduino, and then we have to control that by using an alarm system, so that the alarm makes a sound whether somebody is entering the safety locker room or not. So we can design security applications by using PIR sensor or passive infrared sensor. This is my PIR sensor. This PIR sensor has typically 3 pins. First one is the signal, second one is the power, third one is the ground. So before we actually writing the code for this, let us see how this sensor basically works. Let me take the Arduino. So first one is the ground. So let me connect that, the ground pin. Second one is the power line. So once you apply the power line and the ground line, let us monitor what is the output that is coming from this by using a multimeter before we connect that to the Arduino. So I connect the ground point to the ground, and I connect the signal to the output signal of this ground. So it is showing 0 volt. It's an on and off circuit. It's an on and off. When somebody is present near the field of view, it shows 5 volt. When nobody is present, or when somebody is beyond the range of the sensor, the output goes to 0 volt. When something is detected, again it senses 5 volt. So let me delete this component and connect the signal part to any one of the pin. Let me connect this to 8. And we take a buzzer. Negative pin will short circuit to ground. Positive will connect to any one of the port pin of your Arduino. So one is the input pin, that is the 8th pin. One is the output pin, which is driving the buzzer. So this is a simple security system. This security system should detect whether somebody is present in my secure locker zone, and it has to make an alarm telling that somebody is trying to intrude my safety place. So let us write the code for that. Void setup, void loop. We have 2 pins. One is a IR, the other one is the buzzer. So integer PIR is connected to 8th pin, and 6th pin is connected to buzzer. This is connected to 8. Alarm is connected to 6th pin. So configure both of them as input and output respectively. In mode, PIR is configured as input because we are reading the PIR sensor. In mode, alarm is configured as output. Why output? Because we are driving the alarm. Okay. So first we have to read the PIR. So how are you going to read this? Digital read PIR my data. So I read this my data. So if the value of my data is equal to 1, we know that the sensor will give you 5 volt when some intruder is detected. So in that case, we have to make the alarm to go on. So tone alarm pin 500 hertz, else no tone alarm pin. Okay, that's all. We read the sensor, PIR sensor. If the sensor value is high, we make an alarm sound. If the sensor value is 0, which is the else condition, we don't make any sound. Gradually bring it down. So that is your PIR sensor, which is a passive infrared. Passive infrared means we don't use a separate transmitter and receiver. Whenever something comes under the field of view of this sensor, the sensor would become immediately active, and then it supplies a pulse output. So that is my PIR.